All right, Algebra 1, what's really cool about 5.3 is that I'm not really going to be teaching you anything new. We're just going to be combining what we learned the last two lessons. Okay, so now we're moving into multi-step inequalities. Not much that is too new. So some steps to solving these some things to think about when you're going into this is to distribute first if you can. Then we're going to combine like terms and isolate the variable like we've always done. And then we're going to simplify. All right, so a little reminder before we go is that when you multiply or divide by a negative, okay, by a negative across an inequality, you must change the direction of the inequality. Don't forget that, okay, from the last lesson. So example 2 here. We're trying to get w by itself. That is the goal, right? So there's nothing to distribute. I'm gonna get rid of this 10. So to get rid of this 10 here, right now it's just being added. So I'm going to subtract the 10 from both sides. And then I have 13 is greater than or equal to negative 2w. To get the w by itself, I must divide, because right now it's being multiplied by negative 2. So I must divide by negative 2. And when I do that, I get w on this side. The inequality must switch, right? Must switch. And then 13 divided by negative 2 is, well, I guess we could write that as a mixed number. So that would be negative 6.5. And then you're done. Okay, so one thing to consider, maybe I should say you're not done, just because I'm okay with this answer, but let's try to make them all the way that we did in the first two lessons. So let's move the w to the other side. So if we do that, right now the alligator, here's your little teeth, right? Your alligator's eating the w. So we got to make sure that that stays the case, but we want the w on the left, right? So your solution to this would be, in set builder notation, all answers w, where w is greater than or equal to negative 6.5 or 6.5. Okay, if I were to graph this on a number line, I'd start here at, well, let's say that's negative 6, this is negative 7. It's or equal to, so I'm going to have a filled in circle, and the w's are greater than that, so we're going to go that direction. Okay, so that's what the graph would look like. For 2b, let's try this one. So again, trying to get this y by itself. So the first thing we're going to do is we're going to subtract 11 from both sides. When we do that, we get negative 4y here is less than, let's see here, 32. Okay, so then we're going to divide both sides by negative 4. And then I have 32 divided by negative 4 is negative 8. The inequality must switch. And then I have the y on the wrong side. So we got to switch that thing back, right? So alligator is eating the y right now. So we're going to make that still stay the same, but the answer to this would be all y values where y is greater than negative 8. Okay, so on the number line here, we have a negative 8, and then I might show negative 7, negative 6, something like that. It's not or equal to, so we have an open circle, and it's all things bigger than that. So we're going to go in the greater than direction. So that's example 2. Example 3 is a word problem. Not a word problem, but putting what we learned from words into practice. So this is just saying 2 more than half a number is greater than 27. I don't know that I'll give you too many of these in your homework, but or in your test for that matter, maybe one of them. But yeah, they want you to set it up. So 2 more than half a number. Okay, so half a number, so we can show that by saying half of x, right? Half of a number, 2 more than that though, so we're going to add 2. So 2 more than half a number is greater than 27. So we can show it like this, and then they want us to solve this, I'm sure. So we're going to subtract 2 from both sides, right? And we have 1/2 x is greater than 25. To get x by itself, we have to multiply by 2, because right now we're technically dividing by 2. 1/2 x can be written as x over 2. So I'm going to multiply by 2 on both sides. And when I do that, I have x here, this inequality stays the same direction. 25 times 2 is 50. So it's the x values where x is greater than 50. Okay, that's example 3. Example 4, so we have 4 and 5 to do here, you guys. So for example 4, what we're going to do is we're just going to distribute here. That's the only thing that's new. So we're going to distribute, then we're going to do exactly what we've been doing. So 6 times 5z is 30z. 6 times negative 3 is negative 18. Okay, it's less than 36z. Now we're going to combine our z's. We want all the z's in one place. So I'm going to subtract 30z's from this side, subtract it from this side. This goes away. I'm left with negative 18 is less than or equal to 6z. Okay, then I want z by itself, so I'm going to divide by 6. I have z is greater than or equal to negative 3. Don't change the inequality because you did not divide by a negative. Okay, make sure that that is clear in your brain there. So here, if I want my z on the left, okay, the alligator has to continue to eat that, right? So I have the z values where z is greater than or equal to negative 3. All right, they may have you graph these for example 4. I'm not going to do that for these just to save some time. But I think you know how to do it. We've done a bunch of those already. So example 4b, same thing. We're going to distribute first. So we have 2h plus 12 is greater than negative 24 plus 3h. Be careful there. It's a negative times a negative. Okay. Combine your like terms. So I'm going to actually do this just for fun and to show it to you. I'm going to move this 3h over here. Okay, so if I subtract 3h from both sides, just be careful there. 2 minus 3 is negative h. Negative h plus 12 is greater than negative 24. The reason I did it is because I know I want my variable on the left eventually. So I just wanted to show you that this is a way to do that. Okay, so then I'm going to subtract 12 from both sides. And I get negative h is greater than negative 36. Okay, to get h by itself without that negative, I have to divide by negative 1. Okay, this is where the inequality sign will switch. And so will my negative. It'll go from negative to positive. Okay, so it's going to be the all h values where h is less than 36. All right, let's look at a couple more. For example 5, what's different here? Well, not too much. They just added something to the distributive property here. So we have an 18 out front. Then we are going to distribute this negative 3 out. Okay, so that's kind of a new piece. Not really, though. Negative 3 times 8 is negative 24c. Negative 3 times 4 is negative 12. Okay, negative 6 times 4c is negative 24c. Negative 6 times negative 1 is positive 6. Okay, now combine terms. I like to combine the terms on the same side first. So 18 minus 12 is 6. Minus 24c, just clean that up a little bit, is greater than or equal to negative 24c plus 6. Uh-oh. I know why they did this example. Okay, how do I combine like terms here? Let's add 24c to both sides. Hopefully you're starting to see it now too. The c's cancel, and this says c is greater than or equal to, 6 is greater than or equal to 6. So what happens here? What's the answer, and what does it look like on a graph when I have this kind of thing that happens in example 5? Okay, so for example 5, if you have something like this, it's the same thing as like when we used to do it when we had like 3 is equal to 3 or 0 equal to 0. This is always a true statement. So this means that this could be any number. I can put in any number that I want for 5a. Okay, so you could say the solution is c, where c is any real number. Okay, and we say real because, you know, there are imaginary numbers, so c has to be a real number in the real number system, and we'll get into that later, but just that's why we're putting c as any, not just any number, but any real number. Okay, for 5b, what they're probably going to show you is a no solution. All right, so let's take a look at that one real quick. And by the way, on the graph, this is just a graph that's solid and goes in both directions because it could be anything, right? So you put a 0 here, could be anything. So for 5b though, let's take a look at this one. We have 46 is less than or equal to 8m, and then I'm going to distribute minus 8m minus 20. Okay, 8m minus 8m is just 0, so I have 46 is less than or equal to negative 20. So you have to ask yourself this question. When is 46 ever less than or equal to a negative number? And the answer to that is never. Never. Never the case. This is a no solution. Okay, so you can't graph that or anything. You just have no solution. You're done. All right, guys, that's the end of the lesson for today. We'll catch you guys in class next time.